Okay, we are going to move on to the third video on solving multi-step equations. We are now going to move into solving equations with two expressions, where you have an equation on each side of the equal sign. What you want to keep in mind is you are going to begin by working on each side independently. You're going to work on the left side independent of the right side to begin with. You're going to combine like terms and use any properties on each side until you have a 1 or 2 operation problem on each side. After you have that, you're going to begin to work on isolating the variables to one of the sides using the properties of equality. So let's go ahead and look on this one. All right, so when you look at this problem, we have two expressions. We have an expression on the left, which is 6x plus 3, and we have an expression on the right, which is x minus 21. Now, if we go through the steps of our solving equations, you will notice that over here, we do not have multiple terms. We only have our multiplication operation and our addition operation. So there isn't anything else we can do on this side to simplify the expression. If you look on this side, we're in the same situation. We have our multiplication and we have our subtraction. There isn't anything we can do to simplify that expression anymore. When we're at this step, we go to the step of isolating the variable. Isolating the variable means you either want your x to be all alone on this side, or you want your x to be all alone on the right side. When choosing that, there are a couple things you want to keep in mind. Like we talked about in class, it's easier to deal with a positive variable. So when you're looking at this, you want to look at when you apply the properties of equality, which side do you want your variable to end up in? On this side, 8x is larger than 6x. 8 is your larger number. And when you're using this, you're probably going to want your variable to end up on the right side because 8 is larger than 6. So I am going to choose this side that I want my variable to be on. So this is going to be my variable side, and this is going to be my constant side. Now what I'm going to do is I'm going to apply my properties of equality. I'm going to erase all this so I have a nice clean problem. And just like we've done before, I am going to start with my undoing my addition and subtraction first. Now because I have identified this side as my variable side, I want to look at this expression and I want to get rid of the constant. Okay, because I want my variable to be left alone on the right side. To get rid of my constant, I'm going to undo subtract 21 and I am going to add 21. And like we've talked about before, what I do to one side, I do to the other. I'm going to add 21 to this side. I am then going to have 8x on this side, and over here I still have my 6x, and I'm going to have that added to 24 and my equal sign. Now you can see I have my variables on both sides, and I've already indicated I want my variable to be isolated on this side. So what I need to do is I need to get rid of this side. Now you'll notice the operation being performed between this and this is addition. And so I can apply my subtraction property of equality, and I am going to subtract 6x from this side, and I am going to subtract 6x from that side. And I can do this because I'm keeping my 6x together, and I'm just undoing the operation. When I have 6x minus 6x, I end up with 24 equals 8x minus 6x is 2x. Now I'm down to a problem where I can use division and solve for x. I would divide both sides by 2. X would equal 12. Okay? So what you want to do is you want to treat each side isolated, work through each one to simplify the expressions down to where you just have the two operations, and then perform your properties of equality to isolate the variable to one side. All right, I want you to go ahead and try this one. Try it first on your own, and then I am going to do it step by step, walking you through each piece. Okay, here we go. First thing I'm going to do is look at my problem. I'm going to notice that I do not have any terms I can combine on this side. I do not have any terms I combine on that side. So I know that I have it as simplified as far as I need to in order to continue working. I also know that I'm going to have to make the decision as to which side I want my variable on. 7k is larger than 5k. So I am going to choose that side to put my variable so that I ensure I have a positive variable in the end. So what I'm going to start to do is I'm going to start to look at trying to isolate that variable. I know that I want this variable here, so I need to get rid of that constant. To get rid of that constant, I would add 4 to both sides. When I add 4 to both sides, I end up with 7k equals 5k plus 20. Okay? Now I'm at a point where I have my variables on both sides and one side is isolated. So I want to get rid of the variable on the other side. And 5k is being added to my 20. So I want to reverse that operation, and I'm going to subtract 5k from this side and subtract 5k from this side. When I do that, I end up with 2k equals 20. When I have 2k equals 20, I'm going to divide both sides by 2, and I'm going to have k equals 10. So those are the steps to go through when you have a simplified expressions on both sides of the equation. All right, now we're going to get a little bit more difficult. So like I said, the first thing you're going to do is evaluate both sides of the expression. And on this one, you can see on the right-hand side, I have my simple two operations. I have multiplication, I have addition. On the left-hand side, however, I have parentheses, and I know that I am now going to have to do something else. The one thing I should notice right away is I can get rid of those parentheses using the distributive property. So the first thing I am going to do is apply the distributive property to get rid of those parentheses. To do that, I know I will have 2 times c, and I'm subtracting 2 times 6. Now I'm not going to just leave that. I'm going to keep my equation as intact as possible. Now I'm going to do this. I'm going to do 2c minus 12 equals 9c plus 2. And you can see that that equation now looks like the ones we just did. I have my left side simplified down to just multiplication and subtraction. My right side is simplified multiplication and addition. Now I'm going to go through the process of where I want to think I want my variable to end up, on the left or the right. On this side I have 2c, on this side I have 9c. 9c is larger, so I want my variable to end up on the right. So the first thing I'm going to do is get rid of my constant. And I have a plus 2, so I'm going to subtract 2 from both sides. That will leave this side with a 9c. Now here is the issue that we had last time. I have negative 12 minus 2. Negative plus a negative, remember, makes it a larger negative. So I'm going to have negative 14 and 2c. So I can see here I have my variable all by itself over here is what I wanted to do. Now what I need to do is I need to get rid of the variable off of this side. So I'm going to subtract a 2c from this side and subtract a 2c from that side. What I'll end up with is negative 14 equals 7c. Want to get rid of my 7? I'm going to divide by 7. I'm going to have negative 2 equals c. So if you didn't get this one right, what I would do is erase, put the original problem again, and work through the exact same problem again, watching the step each time and really thinking about what you're doing from step 1, step 2, step 3, and work your way down so you recognize all the different pieces that you did. Okay, now we're going to get into some equations that have some more difficult computation in them. So on this one, the first thing you should notice is we have two expressions. Both expressions are simplified as far as we can go. But I have a fraction over here, which is going to make it more difficult. When you have a fraction like this, you want to try to simplify this down as much as you can, leaving the fraction as a fraction until you have to deal with it. One of the things I would do is I would leave this side as the side I'm going to keep my variable on. So I want to isolate my variable on this side. So to do that, I'm going to keep my 9/2 m, and I'm going to add an 8 to both sides. So that is going to equal 2.5 plus 4m. Okay? Now, I could do one of two things. One of the things I could do here is I could subtract both sides by 4m. To subtract both sides by 4m, I would have 9/2 m minus 4m, and I would do 9/2 minus 4, and I would figure out that. The other way I could do it is this. I know that by reversing an operation, I can eliminate something. 9 over 2 is a division. So if I take 9/2 m and I times it by 2, I can get rid of my 2. So I'm going to times this side times 2 and end up with 9m. If I times this side by 2, I then have to times this entire side by 2. Now, by doing this, I'm doing the distributive property. I'm going to take 2 times 2.5, and I'm going to add it to 2 times 4m. 2 times 2.5 is 5. 2 times 4n is 8m. I now have a problem that I can work with. And so I can take and I can subtract 8m from each side, and I get m equals 5. The other way would have worked the same. I would have just had 1/2 m. So one of the ways you can do this is by reversing the operation there. Another example that you might see is you may see that you have fractions associated with both of your variables. In this case, one of the things you would want to note is that your denominator in both fractions are a 3, which makes this significantly easier because I know how to add and subtract and multiply and divide with fractions, and I know how to add and subtract fractions with equivalent denominators. So we're going to solve this one the same way we would do any other problem, treating the 1/3 p and 2/3 p like any other number next to a variable. The first thing I'm going to do is determine which side I want my variable on, and I want it to be positive. Now over here I notice that I have a negative 2/3 p, and over here I have a positive 1/3 p. I want to have my variable on this side because then I know it's going to be positive. To do that, I'm going to add 2/3 p to both sides. When I have a minus 2/3 plus 2/3 p, I'm going to get a 0. And 1/3 plus 2/3 equals 1. So on this side, I am going to have p plus 7 equals 12. I'm going to do my subtraction property of equality to subtract 7 from both sides, and p will equal 5. So that is another way that you can solve these. Okay, continue working through the ones in your math journal, or go back and look at any that confused you. Make sure you're doing the check. And if there are any that you really are just struggling with, especially if you look at the try thises, then make sure in class tomorrow the first thing I will do is ask for any of those.